Welcome to this module. This module provides an introduction to capacity building and technology. The aim of this module is to provide you with an understanding of the importance of technology transfer and its complexities. The module also outlines technology transfer in shipping energy efficiency in compliance with MARPOL Annex VI, Regulation 23 on the promotion of technical cooperation and transfer of technology. The module also provides an overview of a comprehensive approach to financing. Outcomes. Upon completion of this module, you will be able to do the following. 1. Explain what technology transfer is. 2. Identify the types of information to transfer. 3. Describe the processes and requirements of transferring technology. 4. Differentiate between different financing schemes and engagement. A number of topics are covered in this module. We introduce capacity building and technology. We discuss what should be transferred. We outline technology transfer requirements. Explain technology transfer for shipping energy efficiency, and discuss the features of a comprehensive approach to finance. Any effort to build capacity and/or technology transfer should consider how such efforts are best suited to the current circumstances and needs of the recipients. Capacity building can be seen as incorporating a wide range of activities that are aimed at addressing gaps in the ability of recipients to implement and scale up their research endeavors. Traditionally, technology transfer is commercial or trade-related processes in the innovative chain, which involve the acquisition and use of technology and the knowledge and skills that are needed to operate it. The IMO resolution on the promotion of technology transfer Regulation 23 is intended to support states which request technical assistance. There are several stakeholders that can be considered of relevance. These include the public sector, the private sector, financial institutions, non-governmental organizations, and research and educational organizations. Technology transfer. Discussion will explain the core aspects of the processes involved. Themes include assessing the potential implications and impacts of the implementation of the regulations in Chapter 4 of MARPOL Annex VI. In this regard, there is a particular focus on developing states. Identifying technology transfer and financial needs. Identifying and creating an inventory of energy-efficient technologies for ships. Identifying barriers to transfer of technology, in particular to developing states, including the associated costs. Identifying possible sources of funding. Making recommendations for the development of a model agreement to enable the transfer of technology resources and capacity building between parties for the implementation of the regulations in Chapter 4 of MARPOL Annex VI. Identifying novel aspects of recipients' current status. Technology management. Management of the processes that lead to TT, the flow of know-how, experience, and equipment. Technology transfer management follows the normal continuous improvement cycle of plan, do, check, act. Planning, implementation, monitoring, and review. As with any continuous improvement cycle, the TT processes will take time to be effective. There are numerous complexities to technology transfer and a number of stakeholders who are involved. Stakeholders are technology owners, where the focus is on the product design and the product manufacturing phase, technology recipients, and technology transfer agents. Pull factors. These can be internal factors of the recipient that help to absorb the technology. Can be factors that stimulate the demand for or affect the prices of specific technologies. Push factors. These are factors that increase the supply of technological options by adopting advances in technology. Barriers. These can include a lack of awareness of administrative and industry requirements, MARPOL in general, MARPOL Annex VI, EEDI, and SEEMP in particular, the availability of energy efficiency technologies, technology concerns, the lack of or limited technology supply chain in the region, a lack of trust. This can relate to the lack of trust in the ability to reduce emissions or the ability to reduce operational costs or the compatibility with other measures. Commercial barriers. These include the increased costs for ship owners to take up energy efficiency technologies. There may also be a lack of motivation on behalf of the owners to take up energy efficient technologies. Technology is available to achieve high efficiency gains. It is possible to save 35% of fuel with only a few improvements that require an upfront investment. Such an investment can be earned back depending on the age and type of vessel. The key is the transfer of knowledge, information, and skills. These competencies and this knowledge can be acquired through training, where formal training is combined with open discussions. Open discussions allow experiences to be shared within one stakeholder group or between operational managers of ships, authorities, and administrators. Training can focus on just one or all aspects relating to available energy efficiency measures or assessment methods of technologies. Examples include training in calculating and verifying EEOI and SEEMP, including the development of tools to calculate EEOI and SEEMP. Training can happen at the local or regional level. Sending people to regional training is more conducive to networking and experience sharing, but less adapted to the local situation and more costly. To reduce costs of training, a model training course can be developed for training and work placements utilized. Pilot projects are also a relatively effective tool for knowledge and skill transfer. Transfer of software. Software is the generic term for the processes, procedures, and relevant tools. Software may include working practices, design tools, management tools, and organizational processes. Transfer of hardware. Traditionally, TT has been considered as the transfer of hardware. Transfer of hardware in technology transfer will go beyond a simple sale of equipment, but is more of a long-term collaborative working relationship on the use and development of relevant hardware. To plan for the TT, one of the first steps is usually to do a recipient's Technology Needs Assessment, or TNA. The TNA uses a variety of strategies, including gap analysis and SWOT analysis. The end result is information about the recipient in the following areas: current status, requirement for knowledge, know-how, software or hardware, pull factors, barriers, and so forth. Capacity building in general refers to activities that lead to the preparation of the recipient to absorb the new technology. Capacity building in SIDS requires cooperation between countries and relevant international organizations, regional associations, and with developed countries, as well as among the developing countries. This will enhance the capacity of SIDS in the areas of human capacity, institutional capacity, legal aspects, infrastructure, socioeconomic environment, and so forth. Building capacity in this field should be carried out in a fair and reasonable manner that does not undermine or duplicate existing instruments and mechanisms. TNAY is developed according to clear steps that countries may wish to consider when addressing technology transfer capacity building needs. TNAY employs a number of methods, including examining relevant policies, conducting gap analysis, using analytical tools to facilitate engagement. There are key steps in assessing the capacity gap. 1. Ensure that the capacity needs required to implement technology transfer are translated to the country's goals. Examine the performance of existing systems and identify the capacity deficit and thus the capacity building needs. There are 3 phases in the technology transfer requirements. Phase 1. This phase involves the identification of a recipient's technology and capacity needs. Phase 2 concerns the creation of an enabling environment. Phase 3 involves the design of specific TT projects and initiatives. Phase 1 includes a number of steps. Firstly, a partnership needs to be established between the stakeholders. Then, there needs to be an assessment of the recipient's technology and capacity needs. This must be led by the recipient country. This should be followed by an analysis of national strategies, policies, institutions, and programs that are to be included. The outputs of Phase 1 should be status reports, baseline data, clear targets, and roadmaps for a way forward. Phase 2 concerns the creation of an enabling environment. This includes an awareness-raising process and communication with stakeholders and/or the execution of pilot projects regarding transfer. It also includes necessary legal, policy, and institutional reforms, definition of the problem in order to set objectives, clarify the participation of stakeholders, develop frameworks, and raise the necessary funds. In Phase 3, specific TT projects or initiatives are planned and developed. This phase includes the design, implementation, evaluation, and refinement of action plans for TT, the dissemination of technology transfer information. At this stage, technologies will now be in place and recipients can understand and utilize them. The plan will be based on TNA and CAN results. MARPOL Annex VI, Regulation 23, concerns the promotion of technical cooperation and transfer of technology that relates to the improvement of energy efficiency of ships. Regulation 23's scope of technology transfer is limited to compliance with EEDI and SEEMP. Regulation 23 specifies the following. 1. Administration shall, in cooperation with the organization and other international bodies, promote and provide, as appropriate, support directly or through the organization to states, especially developing states, that request technical assistance. 2. The administration of a party shall cooperate actively with other parties, subject to national laws, regulations, and policies, to promote the development and transfer of technology and exchange of information to states which request technical assistance. This is particularly in relation to developing states in respect to the implementations of measures to fulfill the requirements of Chapter 4 of this Annex, in particular Regulations 19.4 to 19.6. For compliance purposes, the following activities need to be part of TT. Capacity building. This includes the exchange of information and technical cooperation, collaborative research and development on energy-efficient technologies, collaborative activities on ship design improvements, and EETS deployment for existing ships. MEPC 65 in 2013 adopted Resolution MEPC 229/65 on the promotion of technical cooperation and transfer of technology relating to the improvement of energy efficiency of ships. Among other things, it requests the IMO, through its various programs, to provide technical assistance to member states to enable cooperation in the transfer of energy-efficient technologies, in particular in developing countries. In 27 MEPC 69, the group agreed to make clear in the draft provisions that only parties to MARPOL Annex VI could access the database, which would contain anonymized data only, and that the use of the data was strictly limited to analysis and consideration. In 30, the group noted the concerns of some delegations that the flag state of the ship should not be identified to those accessing the database. The group agreed that these concerns could be addressed in the guidelines to be developed by the organization pursuant to the management of the database. MEPC recognized that in view of projected increase in the world's population and trade, market-based measures may be necessary to supplement the adopted technical and operational measures to ensure even further reductions in GHG emissions from international shipping. MEPC 63 noted that there were several possible uses for revenues generated by an MBM for international shipping. These included incentivizing shipping to achieve improved energy efficiency, providing a rebate to developing countries, financing adaptation and mitigation activities in developing countries, financing improvement of maritime transport infrastructure in developing countries, supporting IMO's Integrated Technical Cooperation Program. All industries are looking to become cleaner, greener, and more energy efficient, and shipping is no exception. Improved energy efficiency means that less fuel is used, and that means less harmful emissions. Estimates suggest that ships' energy consumption and CO2 emissions could be reduced by up to 75% by applying operational measures and implementing existing technologies. Promoting these technologies and operations to improve energy efficiency in the maritime sector will help shipping to navigate into a low-carbon future. These strategies will also benefit ship operators with a reduction in fuel consumption and therefore a reduction in costs. The IMO has a role to do the following. 1. Help identify and assess existing EETs. 2. Play a role in promoting the development and uptake of EETs. 3. Assist states in identifying their needs with respect to EETs. 4. Help identify opportunities for technology cooperation among states with respect to EETs. Some examples of aspects that need to be part of the framework are stated below. Use economies of scale. Engage with private sector financing. Use innovative financing schemes. Focus on major energy saving measures. Promote EETs. Promote data collection and other management elements to ensure quantified achievements. Shipping is an industry that is mainly driven by the private sector in both developed and developing countries. The low-carbon transition will require large-scale mobilization of all sources of private sector investment. Governments could play a catalytic role and create the right incentives that can help attract additional private funding. However, there are barriers to private sector engagement in the ship energy efficiency, which need to be identified and removed. Split incentives are a barrier to the deployment of energy efficiency measures in a maritime context. There are mechanisms for overcoming the split incentive problem as a barrier to investment in energy efficiency and to sharing the benefits of the upgrade between parties. The structure of the industry, which has evolved over centuries, cannot be changed. The main changes need to be in the development of innovative financing schemes and legal frameworks for sharing the risks and the rewards. Energy management and CO2 reduction will benefit from economies of scale, for example, larger ports and ships. Arrangements to develop multinational and multi-corporation joint initiatives should be encouraged. Alliance building among countries, shipping countries, other institutions to create larger pools of resources needs to occur. Ship energy efficiency measures are promoted to improve vessel efficiency, reduce fuel consumption, and lower emissions. There are large numbers of energy efficiency measures that have been advocated. However, it's only a few of these measures that provide most of the energy-saving potential. It is proposed to concentrate on major EEMSs for technology transfer purposes. IMO could play a significant role in TT. They could help to define the framework, push for reforms and capacity building, concentrate on removing the barriers, help to identify and secure resources for project funding at macro level, such as GHG Fund. At the national level, and since TT for energy efficiency goes beyond the conventional maritime administration functions, the establishment of new entities may be required in order to deal with the specialized task of maritime GHG emissions control and reduction. Thank you. This slide completes the current module.